Alright, notes 5.1, perimeter and area. So, in the first three sections of this unit, we'll be reviewing perimeter and area of different shapes. Most of these you've already learned, so you'll be expected to learn very fast. So we're just going to review some quick definitions. Perimeter. So the perimeter of a closed plane figure, the perimeter is the distance around it. So it's the distance around the figure. So you just go around the outside, so it's the distance around the figure. Whereas the area of a closed plane figure, this is the number of non-overlapping squares of a given size that will exactly cover the interior of the figure. So something, if you would draw, this is 2 by 3. Well, that has 1, 2, 3, 4, 5, 6 squares. So we know that the area is 6. So this is 2 by 3. That's area of 6. There's 6 non-overlapping squares of that plane figure. So the sum of areas, if a figure is composed of non-overlapping regions A and B, then the area of the figure is the sum of the regions of A and B. So if you have two different figures, you can add them together to give you the total area of those regions. So if we look at this, the perimeter of a rectangle with base B and height h is given by the formula. Well, perimeter is around the outside, so perimeter is around the outside. So we have B, we have an H, another B, and an H. So the perimeter is equal to, we have 2 bases plus we have 2 heights. So 2B plus 2H. Whereas the area, well, remember we want those squares. So the area is going to be the base times the height. So the area is however many are down here by however many go up here. So the area is base times the height. Now we can estimate area. So if we're given a shape without fixed sides, what we would have to do, we'd have to place a coordinate grid over it, and I know in your paper it's very hard to see that coordinate grid, so I'll just show you how you can figure this out, and then we can count the regions and estimate the portions. Well, if you notice here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There's 18 of these that are partial. Some are more than others. Well, we know that we have 18 that are partial, and then we can count all the squares that are covered. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And so there's 16 complete covered. So what we can do, since it's a partial, well, some are complete, more than others. We can say that since it's partial, we can divide it by 2. So we can say that there's 9 plus our 16. So we could say that the area is about 25. So the area is about 25. So we took our partially ones, divided it by 2. Some are more than others. And then we have the 16 that are completely covered inside. Now if we look at this other figure, well, what we can do is we can break this down into smaller squares and rectangles. Well, we know that we can extend this line up here. So now I have this region right here, which is 2 by 1.5. So we can say that 2 times 1.5, that gives us 3. So this area is 3. We'll change colors. So we have another rectangle right in here. Now I know that this looks like it's 4, but we know that this is 1.5 If this whole thing is 4, that means the top is 2.5 because this entire thing is 4. So 1.5, that's 2.5. And then once again, we have to figure out, well, how long is this entire thing? Well, we have 2 and 2, so it's 4. So this is 4 by 2.5, so we have 4 times 2.5. That gives us 10, so this is 10 units in here. And then we have one last square out here. Well, this is 2.5 by 1.5, so we do 2.5 times 1.5, and that gives us 3.75 units. So the last thing that we can do is to find the area. We can add all these together. So we have 3 plus 10 plus 3.75, which gives us an area of 16.75. To find the perimeter, we just add up all the outside part. Choose this one. Alright, so we know that we have 2. So this is 2. So 2. This whole region was 4. So 2 plus 4. This region here is 2.5 plus 2.5. This region is 2.5 plus 2.5. 1.5 plus 5 plus 2 and plus 1.5. So this is the perimeter. We add up the entire outside. So we have 6, 16, 17 and a half, 22.5, 24.5, 26. So 26 units is the perimeter. So that's adding up the entire outside. Actually not. This is 5 and 6. That's 11. Let me just erase this. So this is 6 plus 5, and that's going to be a 3 and a 7 plus 3 plus 7. So it's actually 21 units. So it's 21 units right there for the perimeter. Now a fixed perimeter and area, well, what's the maximum area of a rectangular garden with a perimeter of 48 feet? Well, if we think about this, well, if our perimeter of a garden is 48 feet, well, we can say it's 1 by something. So if it's 1 by 1, what we want to do is we do 48 minus 2, and then we're going to divide that answer by 2. Well, 48 minus 2 is 46 divided by 2. That means it's 23. So the area of this one, 1 times 23, is 23. Now if we do it with a 2, so 2 by what? Well, 48 minus 4 divided by 2 will give us 22, which will be 44. If we do it by 3, 48 minus 3 and 3, so 48 minus 6. So 48 minus 6 is 42 divided by 2. That gives us 21. So this is going to be 63. Well, now if you're noticing, well, what's happening to the area of these as the sides, as one side's increasing and the other side is decreasing? Well, if we can look at this, 48 minus 8 is 40 divided by 2. That'll give us 20. 4 times 20 is 80. Well, we start to notice that the area is increasing as these numbers are getting closer. So when these two numbers get as close together as possible, we will have our greatest fixed area. Well, if I think about that, well, what two numbers is going to give close to possible? Well, you can get to 12 by 12, because 12 plus 12 plus 12 plus 12 gives us 48. 12 times 12 is 144 feet squared. So the maximum area that our rectangular garden can be is 144 feet squared. Because if we start with 1, it's always going to be the area is always going to be getting larger as one side is increasing and the other one's decreasing. And if we look at the opposite way, well, what's the minimum perimeter of a rectangular region with an area of 900 square feet? Well, if we know that this has an area of 900 square feet, well, if it's 1 times 900, that's 900 square feet. So this is also 1, this is 900. If we add this all together, we get 1802. Well, if it's a 2, 2 times what will give us 900? Well, 2 times 450. So this is 2 feet by 450 feet. Should put it. So 2 times 450 is 900. Well, that means this is 450 here. That'll give us 904 feet. And we can do this for 3 feet. So 3 feet by 300 feet. Well, that'll give us an area of 606 feet. Well, if we notice that the area or the perimeter is going down in each of these, and I can continue and look at 4 feet by 900 divided by 4 gives me 225 feet. Well, that's going to give me 450 plus 8, 458 feet. Well, the area or the perimeter is going down, so the minimum perimeter of a rectangular region with the area of 900 . So we know we want the two areas, since we want the minimum perimeter, the two areas that are closest together, just like this, the previous one. So the two that'll give us close together, if we think about taking the square root of 900, well, that'll give us 30 times 30. So if we do 30 times 30, we get an area of 900 feet squared, which will give us a perimeter of 30 plus 30 plus 30 plus 30, which is 120 feet. So the minimum perimeter is 120 feet, whereas the maximum perimeter is 1,802 feet. Now find the area of a rectangle with these vertices. Well, if we plot these 0, 0, 0, 2, 5, 0, 5, 2, we have our rectangle here. We know that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 squares in there. So we know it has an area of 10 units. Or you could have said it's 5 by 2. So the area is 2 times 5, which is 10 units squared. If we look at question number 2, we can plot these. So we have 3, 1, 3, 7, 9, 1, and 9, 7. Well, once again, it's 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So it's a 6 by 6. So there's going to be 36 units squared. So area is 6 by 6, which is 36 units squared. Now try to complete 9 through 18, and we'll go over them tomorrow in class.